Okay, this problem is where I give away that I'm left-handed because I've left the left side of this open to do calculations on instead of the right side. Yep, so graph the function and identify the vertex and the axis of symmetry. Well, I'm going to start out by just giving you this really important equation, which is the equation for the axis of symmetry is x equals negative b, sorry, it doesn't want to write up there, negative b over 2a, okay, where y equals ax squared plus bx plus c is the form of the equation, okay? And you can see that y could just as easily be f of x, so I could say, okay, since they wrote it as f of x, let me just get y out of there and write f of x. They mean the same thing. I actually prefer f of x, to be honest, because then we can say, well, I'm going to show you why I prefer it. But let me first find out for this equation what's a, what's b, because those are the two values that we need. So for this equation, if we said x equals negative b over 2a, then that means that it would be x equals the negative of whatever the b value is over 2 times whatever the a value is. And what is the b value? The b value, as you can see right here, is in front of the x term. Don't say it's 4x, it's just the 4. Okay, so negative 4 over 2 times a. And what is the a value? The a value is the number that's in front of the x squared. And what's in front of the x squared up here? Well, you don't see anything written, but that's an implied number 1. Okay, so negative 4 over 2 is negative 2. So the equation for the axis of symmetry is x equals negative 2. So any answer that doesn't have that is already wrong. Cross that one out and cross that one out. Wrong. Actually, let me change the color on that. Make it a little bit easier to see that we've eliminated it. Okay. Now, what's the vertex point? Well, the vertex point is going to be, it's going to have an x coordinate. It's a point, right? Vertex point. It's going to have a set of coordinates where whatever you got for x equals, for the axis of symmetry, x equals negative 2, that's what the x coordinate is going to be. It's going to be negative 2. And why is that? Because all points on the axis of symmetry have an x coordinate of negative 2. And since the vertex point is on the axis of symmetry, it must also have an x coordinate of negative 2. So since we already know the x coordinate of the point that we're looking for, we can then just substitute that value in for x and see what comes out for y. Now, the reason I was going to say that I like f of x instead of y is because what we can do now, this is the general form of the entire line, but we can also write this. F of, and then put the point in, f of 2, sorry, negative 2, because that's the point that we're looking to find equals. Okay, now our equation, I should actually write our equation. So let me get rid of this and write the equation. We've got really an equation of f of x equals x squared. This is our equation given in this problem, plus 4x plus 1. And then we say, okay, then what's f of negative 2? That's the point we're looking for. That equals the entire equation you write again, but you put parentheses wherever there's a variable, and inside the variable, or I'm sorry, inside the parentheses you put the value of the variable that we are testing or trying to find out the y coordinate of. Okay, so f of 2, otherwise known as y, equals negative 2 squared is 4, plus 4 times negative 2 is minus 8, and then plus 1. And if we do 4 minus 8, we get negative 4, plus 1 is negative 3. So f of negative 2, meaning negative 2 is the x-coordinate, gives you an output of negative 3, meaning negative 3 is the y-coordinate. So we need the point negative 2 comma negative 3, and C has that, and B does not. B does not have negative 2 comma negative 3, so it can't be that one. And one of these answers you can eliminate straight away based on other information that you know. I just want to point this out. Notice that this says x squared. It does not say negative x squared. The coefficient of the x squared term is not negative. Okay, so when the x squared term is positive, we're going to have a graph opening upward. Yeah? B does not open upward. B opens downward. That would require an equation that had a negative coefficient of x squared. So right away you could have crossed that off. Okay, but anyway, that's how you do it. You use negative b, x equals negative b over 2a, this equation here at the top, making sure that you have it written in this form of either y equals or f of x equals ax squared plus bx plus c, and then identify what a and b are and plug them in. You will have the axis of symmetry, x equals whatever resulting number. That'll be the vertical line at that point. Okay, and power's back on. And then you can plug that value that you got for x back into the equation to find out the resulting y value, and those x and y coordinates will be the vertex point. Okay, we're going to do this one more time. I split these problems up. It says 6 and then 10, just to lay out the test a little better so that it fits on a lower number of pages. So 6 and 10, though, are similar. So let's go to number 10 now and see. Okay. Now, if you were listening to me on the last slide, and you probably were because it's all connected video, to you it's just a continuous video with a different image, then you would have heard me say that if you have a negative for the x squared term, then it's got to open downward. The graph has to open downward. And it does have a negative x squared term. We have negative 2x squared. So we know that, not knowing anything else, we know that our parabola should open down. And that means that we can straight away eliminate C, because it can't be that. Okay? So now what we can do is we can take what we know to be the equation for the axis of symmetry, and we can plug it in. That equation is x equals negative b over 2a. Okay? And if we identify what a and b are, I'll underline them up here. A is negative 2, b is positive 2. So we say the negative of the b value, which is 2, over 2 times the a value, and the a value is negative 2. So what do we get as a result? We get negative 2 over negative 4, which simplifies down to 1 over 2. So that's x equals 1/2, and x equals 1/2 is the axis of symmetry. That isn't a positive number for x, so that means that we should be on the positive side of the y-axis, the positive side of where the x's are positive. So what can I eliminate? I can eliminate a, because that already doesn't land that axis of symmetry right here. That's below 0 for x, right? That's x is less than 0, some negative number. Okay. Let me just box this part out. All right. Well, what we can do now then is take the original equation and plug in 1/2 and see what we get. So this one's a little bit trickier because they're fractions, and I know that that's a little bit dicey for some of you, not super comfortable with fractions. F of x equals negative 2x squared plus 2x minus 1. Um, as I said in the last slide, or not in the last slide, I think I said it in the last video, if you know you should know something, fractions is an excellent example, and you don't know it yet, and the keyword is yet, because just because you don't know something doesn't mean that it's beyond your abilities. Okay? If you don't know something yet, then if you want to get good at math, and let's face it, hard to get good at math if you don't understand fractions, then at some point you're going to have to invest in that idea. You're going to have to invest in learning fractions. And so the sooner the better. So maybe consider making that your summer improvement project for yourself. Okay? Just a suggestion. What I'm doing now is I'm rewriting the original equation with the x coordinate of the point I'm looking for in there. Because if the axis of symmetry is at x equals 1/2, then every point on that line, including the vertex point where our curve runs into the axis of symmetry, will have that x coordinate. So then we know we can plug that x coordinate in to find out what's the resulting y value. So we say f of 1/2 equals, and now let's do this in parts, -2 times, that becomes, I'm just going to calculate and put it in pink here so you can see what I'm calculating, that becomes 1/4, okay? Plus 2 times 1/2, 2 halves is equal to 1, minus 1, okay? Now, keep going. -2 times 1/4 is -2/4, which simplifies to -1/2. -1/2 plus 1, just fun fact, -1/2 plus 1 is 1/2. And then if you subtract 1 away, you're down to -1/2. And so I got some stuff in the way here, but f of 1/2 is equal to -1/2. So we have a point that is 1/2, otherwise known as 0.5, comma, -1/2. And I say 0.5 because you can see that's what they're using. So I'm going to write that here in the middle, and we'll just, I'll put it over here. We've got a point of 1/2 or 0.5, comma, -1/2 or -0.5. And where do we see that vertex point? We see that on B, the one that I've just written it at. Okay, since that's the only choice, it's going to be B. Okay. Yep, and that's how you do these. You first use x equals -b over 2a. I can give you that formula for the test, but you're going to need to know how to use it. You're going to need to know how to identify b, how to identify a, and then when you plug it in, you know that that's the axis of symmetry, and you're allowed to use that x coordinate. You must use that x coordinate in the equation to calculate out what the matching y is for the vertex point. Okay.